My name is Oleksii Konashevych. I'm a PhD fellow in the program Joint International Doctoral Degree in Law, Science and Technology. I'm presenting today blockchain anchoring of public registries because there is lots of hype about the use of the blockchain in the world and especially in electronic governments as well. So I'd like to start with busting some myths. Estonian government has never used the blockchain, and here is the official statement on their website. The main governmental system, e-governance, which is X-Road, is not a blockchain. And at least there was one project which was discontinued, notarization with BitNation.
Which I initiated.
All right. Honduras has never developed the land registry on the blockchain. I spoke with the founder of Factum Inc., who tried to initiate this project in this country. And he confirmed they discontinued it. Sweden has never used ChromaWay for real estate registry. I spoke with one of the co-developers of their DLT platform, which is, by the way, centralized. It's called Chromopolis. In their white paper last year, they wrote that, well, actually they didn't introduce any project in cadastral registry as their public document. And however, they 3 months ago demonstrated on YouTube their laboratory prototype app for deeds, but it's not at the state level. BitClan, Ubiquity, never ran cadastral registry in HANA, and their website is more dead than alive. The latest news dated on 2017. Cook County in Chicago never ran a state registry, and I spoke with the founder of Oleksii, who tried to introduce this project there, and they discontinued it. Bitfury never developed cadastral registry on blockchain in Georgia, in the Republic of Georgia, and in Ukraine. And I spoke with developers of the system, Exonom. This is the running project in these two countries, but that's not a part of the cadastral registry. They're just doing hashing records from the cadastral registry. And this is also centralized DLT platform. The use of the blockchain. What does it mean? When I say I brush my teeth, everybody understands the same what I'm doing. When I say I use the blockchain, it means nothing because there are lots of ideas and not all of them are good and very well suitable for any particular case. So let's have a bigger picture, what we can do with the blockchain. First of all, it's cryptocurrency. That's clear. It was designed for cryptocurrency. Another function, another feature was from the first day of the blockchain as actually you can insert data with the transaction, some arbitrary data that you want to store in the public repository. The second generation of blockchain platforms brought us tokens, smart contracts, and decentralized apps, which are actually not necessarily contracts and not necessarily decentralized and not necessarily apps, but it's just a way to automate the transactions and to create some sort of software on top of the blockchain. And these two actually is the result, is the outcome of these two first. If you want to know more about the blockchain, I highly suggest you these two papers, which are the most deep analysis and, well, let's state of the art in this domain of data insertion. So let's talk about how to insert data. This feature was from the very first day of the first blockchain, Bitcoin, but it wasn't actually designed for that purposes. If you want to insert your data, your file, your message, your whatever you want to insert in the blockchain, you need to spend some coins, but that's not a payment. You need to apply some special scripts, and to spend some coins, you burn these coins. Depending on different scripts you use in the blockchain, you can insert up to 50 kilobytes each. So if you have your data and you want to keep it on the blockchain, there are actually two ways. First, you insert the data itself. But if there is an issue with privacy. You don't want to share this data, but you want to secure this data. Instead of that, you can insert a hash sum. I hope you know what does it mean. So you just apply a cryptographic hash function, and you getting this hash value. You insert with the transaction, with the spending of some coins, you insert this hash sum in the block. If you insert the data itself, this data becomes immutable. No one can change it, no one can delete it. If you insert a hash sum of this data, it means the hash is immutable, but not the data. So if the government, or if you want to this way to protect your files, you have to carefully think about to secure the initial data. Because in this case, the only thing the blockchain can do for you is actually to verify, you can verify if this data, your original data, is still original, if it's not changed. Another thing which blockchain can bring you in this case is timestamping, because all transactions are chronologically stored and you cannot change it. So when you retrieve some data from any particular block, you definitely know when it has happened. This data is always permanent and accessible 24 hours. It's public, and what is interesting about public blockchains, they are self-organized. This is a self-organized infrastructure. So if we are thinking in terms of the use of the blockchain by the government doesn't need to care about the infrastructure itself. The government just use this infrastructure and it's self-organized. Let's talk about cryptography. So if you sign your data using just traditional way of digital digital signature of asymmetric cryptography. So here is an input. You take your data, your file, your contract, whatever you want to sign, digitally sign. Here, when we're talking about blockchain insertion, this is actually the same. So you are using the same asymmetric cryptography. You sign using your private key these transactions. But the only difference in this story here is that you insert the payment script, your data, your file, whatever you want to protect, digitally sign and send it to the blockchain store. But there are more differences if we compare these two things in the context of public key infrastructure. So there is no public key infrastructure in the blockchain, but it doesn't mean that you cannot develop on top of the blockchain your own public key infrastructure. And what is interesting, the blockchain is a kind of public key infrastructure, though anonymous. When you use public key infrastructure, typically you deal with lots of technical standards, procedures, regulations in its well-developed domain. And here, well, we don't have officially recognized standards, but there is the first standard applied thanks to Australians. So go Australia, we need standards in this domain. In public key infrastructure, there are two other things which is very important here. These are trust service providers or certificate authorities. Basically, these trusted third parties, and their aim is to certify, to verify the identity, who is who in this infrastructure. And there is another thing here, is time-stamping authority. This is also trusted service, third-party service, which issue a timestamp when you make a legal transaction. In the blockchain, we don't need, because the blockchain is a time-stamping machine itself. If we want to design the system, so we have, for example, the cadastral registry and the blockchain, and we want to insert data, to hash records. So there are three things we have to deal with. First, identity. The second, bidirectional relation between the cadastral registry and the blockchain. and standards. So let's talk about identification, because money and transactions are anonymous. On the blockchain, we have to think about how we deal with identity. So for that reason, to know, for example, blockchain addresses which belong to clerks of the public office, of the register office, we need a public key infrastructure. There is another way how to deal with it. We can publish data from unknown addresses, but when we insert data, we attach a digital signature to this data. So by digital signature, we know who is who, and so again, we need a public key infrastructure. There is another thing, bidirectional relation between the cadastral registry and the blockchain. And here is the project introduced by Bitfury in Ukraine and Georgia, based on their system Exonum. So on top of here, you see the cadastral registry, which is state-owned system. It is closed. It is only restricted number of people have access to this system. And when they make a new record in this system, they calculate a hash sum and send it to Exonum. Exonum is also closed centralized system run by this company with, well, it's semi-governmental, let's say, so that's joint project of the government and of private company. And this Exonum works like this. So they hash the whole state of the ledger once a day, twice a day, and they send this hash record on public blockchain. First it was Bitcoin, now it's Emmercoin. And let's consider how it works and the possible way of attack to the system. So we have a cadastral register here. Alice owns this land. And we calculate the hash sum of this record and send it to the blockchain, to the block. So we have here a block with some other transactions. So we know that our hash sum lives here. And then Alice sold Bob her land. And so now we have another record, another hash sum, and we send it to the block. And it's not necessarily the next block, because it can happen many years after. And here, there was an attack to the system, an authorized change of the record. So now we have, it's clear that we have another hash sum of this record. And the system automatically sends this hash record on the blockchain. And now, while you see this picture, you see what has happened. This is an authorized change because you compare these two hashes, and you know, and you see this part of the story. But in reality, in the prototype, you don't see this part of the story. So you, as an observer of the system, of this part, public part, you don't know what's happened here. This is the problem. So, and even if we talk about Exonum, you don't even see this part as well. It is also closed, so we don't know what's happening there. So we have to carefully think about better design of the system, a bidirectional relation between these two systems, not only one way, but also another way. And of course, for that reason, we need standards, we need good practice, we need procedures, and there are a lot of questions. How can we use the blockchain, or how government can use the blockchain? So, for example, if in one government, two different departments use different blockchains and they're incompatible, that's an issue. Or let's say one department uses the blockchain with 3 nodes, another department uses a blockchain with 3,000 nodes. How do we measure which is secure? There are no answers right now for that case. There is another issue, which is called permissioned blockchain. This is misrepresentation of truth. Why? Because there is Satoshi Nakamoto who wrote this thing, and he designed the concept of the blockchain, and it was implemented in Bitcoin and similar systems. And it is attributed to distributed, uncensored, immutable, and public technology. So when we say permissioned and centralized, We cannot say this is a blockchain, because the blockchain is uncensored, is public and immutable. It's better to say if we're dealing with centralized, permissioned, private systems, it's better to say distributed ledger technology. So we don't mislead people and thus don't misrepresent the truth. Eventually, we came to the conclusions. So if our aim is to decentralize the system, any attempts to perch the blockchain on top of the centralized system are doomed to failure. Why? Because in the end of the day, someone has a backdoor to the system. We can think in terms of decentralizing system, but we still, in the end of the day, have to deal with third parties. We need third parties, trusted third parties, for lots of reasons: to certify identity, to verify some facts of our life, birth, death, marital status, whatever. But they're not necessarily also centralized as well. And the real issue is not in the blockchain. Blockchain is just a tool. We have to think about the paradigm of the governance. If our government is centralized, hierarchical, organized, there is nothing to do here with the blockchain, which is distributed, uncensored system. Thank you very much for your attention.